V10?
V10.
Yo,
Yeah.
work-
Okay.
Yo, Beast, I got you.
Okay.
All right. So
Rescued.
so look at this, Jesse. All right, hold on. Let me turn you up. 1
You
second.
gonna answer my question though? He was
I
working
gotcha.
with me. Are you gonna work with me, or are you just gonna keep him from answering my question?
No, I'm going to explain to you what we're looking at here. So the 24 offset that you're looking at for this and also for distance is off because of this intersection difference. So that's why this is in bold, because this is the primary driver of what causes, these offsets for this. And then also for the globe with respect to the observer's position, for the true position, that's how much they end up being off. And we talk about how there's a common offset error between us when we take these measurements, and it's this half gamma amount. It's what's predicted as curvature. So in this instance, we're off by 4 arc minutes. The globe's true position is off by 45 arc minutes. The difference between those two is the 4 here. Like when we go through all the stuff that we talked about earlier in relation to gamma, that's what this is. Like the elevation that we derive based off of the star and how it's like off is less relevant than it is to talk about the geometric intersection, because the difference between these two is what is predicted to be Earth curvature. So these two amounts should be reversed, and then that would cause the globe to be off by 24 and we would be off by 45. The same with Pikes Peak, like all of them or whatever. But there's no issue with this doing geometric comparisons. Go ahead.
Well, okay, so is it true that the celestial theodolite gave an angle that equated to 1396 meters of delta height between the observer and the mountain peak?
Yeah.
Okay. Is it true that that was 24 meters in error from the real delta height?
Yep.
Okay. Now look on H. H12. 1398. Is that the predicted geometric globe drop from horizontal delta height prediction for the globe? 1398.
Yep.
Is that 1 meter different than 1300, or 2 meters different than 1396?
Yep.
So the celestial theodolite gave an angle that was within 2 meters of the geometric globe prediction for that delta height.
Well, only because the occlusion didn't occur earlier, which the globe would have predicted for their geometric alignment. So if you notice here in H13, you'll see that the globe is off by twice the amount, right? And that has to do with this gamma
You
relationship
said that's a straw
that we
man.
share.
Yeah, that's a
Oh.
complete straw man. No glober supports your method of
Oh.
deriving what you got in H13 there. No glober does. Okay?
Right. Well, let's
A
clear
straw
this
man.
up real quick. Let's clear this up real quick. Saying no glober agrees with this is an appeal to consensus. Completely irrelevant argument. Means absolutely nothing. Couldn't mean anything less. Now,
It means it's a straw man.
No. It does not. It means that you guys formed a consensus and are appealing to your own selves as an authority. 1 second, Eludius, talking to Jesse here. This is a rare moment. So
I should say.
that means absolutely nothing that you guys all got together. Suppose we all got together and said that it was perfectly valid. Would you guys all change your mind? No, that would be retarded. So let's look at this real quick, which I was going over with earlier with Ruhif on occlusions and finding the geometric intersections and how that would relate to the true position. So here
Sharing
we go.
your screen.
Oh, yeah, sorry. Let me share my screen real quick. So if you can join this. So we go down, where was that under? That was in refraction, no.
What's worth, you are allowed to say your own theory. You're just not allowed to say what our theory
Pull
is.
this up. Okay. So they use an occlusion. If there's refraction, if the distance is great enough, they subtract the refraction amount and they reference the true position from their observer location. Okay. What we're doing here is we have an occlusion, we have a refraction amount, We're subtracting it from observer location and looking where the star is geometrically. Is it aligned with what the globe predicts, or is it not aligned with that? Now, that's what we're referencing. To say that that's a straw man of the globe, you would have to say that the French surveyors were straw manning the globe as they were geometrically mapping the stars to the ground over France.
They were correcting for refraction. You're not.
Incorrect. They were subtracting refraction out to reference the true position. That's exactly what we're doing.
The true position. Remember,
And-
Jesse, I
and
said
you're
that?
And you're starting with the refracted position and not subtracting it out and assuming that that's the true position. It's not. Refraction curves light. When light curves, something appears where it is not. When light curves, occlusions occur at a different time and location than they otherwise would. That's why I think it's important for people to understand that the globe geometric prediction of 1398 meters is only 2 meters off from the celestial theodolite results, while the flat Earth is 24 meters off. And basically, it's like, are you saying that the celestial theodolite method doesn't work in this particular case? I mean, if the celestial theodolite method works to give the true angle to the mountain, then it should work.
Listen,
It should work on a flat Earth,
listen,
and it should
Jesse.
work on a globe, right?
It's very simple.
Or no?
If
Well,
the
let me
celestial
stop you
refraction,
real quick.
hold on, real quick. Celestial refraction incorporated, right, at that angle for that observer height to, that refraction right there, 9 arc minutes, 58 arc seconds. Do you agree with that amount of refraction for this
Where?
for this observation? In Astro Refra Stellarium. Stellarium puts 9 arc minutes and 58 arc seconds of refraction into consideration for this angle. Do you agree with that?
I'm not sure exactly what you're asking, but
The blue
have
line.
I do believe Stellarium's
C16.
I do believe Stellarium's application of refraction is quite accurate.
It's accurate. Okay. So that being said, go ahead, Alan.
All right. So, to reference the star's true position, which is what the people did in France, that's exactly what we're doing. Whatever you said at the beginning, where you said you're starting with the thing and assuming this and all, none of that's true. All we're doing is referencing the true position at observer location at the time of occlusion. It's very simple.
So, were those stars that they were occluding?
That is hold on one second. If were the French doing the same thing that I just said, they watch an occlusion, and if there's refraction needed to be accounted for, they subtract it, right? If not, we can read this real quick. You want to read it out loud? I don't have my glasses on.
I got it.
You got me? No, Jesse,
Just
you
go
got
to
me?
the right a little bit.
I have never seen this before. I don't know what this is.
Yeah, I got you. This is a manual of spherical astronomy by William Chavant. Now, William Chavant is referenced in the Nautical Almanac and Ephemeris supplement, where they talk about how to apply refraction for spherical astronomy and whatnot. So he's a reference given in here, and some of the highest authorities on positions of stars in relation to the ground. So in this book, he makes a reference to what the French were doing in terms of they would see an occlusion, they would see another occlusion, and then they would subtract the timing difference from that to get the sidereal time difference if they only knew their local time. Now, they make a mention here that at a great zenith distance, we should compute several refractions, but under 80 degrees, the refraction R, isn't that much. So if their zenith distance is, 20 degrees or lower, they're saying account for refraction to remove it. So all they're doing there is looking at the geocentric position, the true position from their observer location. That's how they're getting that calculation. That's all we're doing here for the globe and looking at, did it align with what they predicted geometrically? And they're always, off. And the amount that they're off and how much we're off is shared by that common elevation difference between us, which is this Earth curvature amount. So as you'll note that, the prediction here is off by 4 arc minutes, but the globe prediction in terms of geometric alignment is off by 9 arc minutes. In other words, the elevation difference between them for the alignment didn't cause an occlusion on a globe, and it occurred later. But we share that same gamma amount. It's proportional in every single measurement. So I can show you real quick a comparison. For Pikes Peak, it comes out to be 2 arc minutes. 11 was actually negative because it was above the peak or whatever at the time of occlusion for the geometric position here. And then for the globe, they say that it's at 11 arc minutes below. If you add these two together, you get the drop over distance. In every single measurement, it's like that. So to say that that's irrelevant or that we're strawmanning the globe or whatever, but we're somehow preserving the arc length and gamma or half gamma over it is that doesn't make any sense. That can't possibly be a straw man.
So are you correcting in H13? Are you correcting for astronomic refraction like the French were?
Do you understand that they were subtracting it out to get the true position? And we're only referencing the true positions for flat Earth and globe Earth. So yes, we've subtracted out the refraction.
Unless the time of the occlusion was affected by refraction, and that's the issue.
What?
What?
The globe position,
sense, dog. There's one.
Anybody who knows physics recognizes that the time of the occlusion will have been changed due to refraction, if refraction is a thing. So you
You're
can't.
changing your entire argument.
So would it? This is really the $1 million question here. Would it be fair to say then that the celestial theodolite method cannot be indiscriminately used to know the true altitude angle to a mountain peak? Because sometimes it matches the globe prediction, sometimes it matches flat Earth and stuff. It just can't be used?
No, not at all. You can actually subtract the difference and get the alignment to what it would be for flat Earth. That's and we could show that for I have it done for Pikes Peak here. So the flat Earth variant of it would be, hold on, let this load in. When you subtract the difference and realign it and then do the same for the globe, which, this is going to be a post edit per, what do you call it? Information. So I misunderstood what he was saying there. And I agree to what he said. It can't indiscriminately get the exact mountain elevation, but it is closer than what the globe predicts. And we do end up going over that. But I just wanted to make that clear for anyone watching this or whatever, just a real-time correction to that. Preserves the arc length and all of that. You get all the same angles, but the globe ends up being off by the full 13 arc minutes for what they were off. And then if you were to reverse it and say, the star gets occluded at the geometric alignment for the globe relative to the observer, then the amount of offset would change. Flat Earth would be off by the drop over distance.
That doesn't
exactly.
So 1 second. So to say, would you say it's indiscriminate? No, literally the opposite. That's why I'm here every week to doing this and going over it.
No, but that didn't answer my question.
Now, again, I misunderstood that, and that was specifically to deriving the exact elevation of the peak. Again, that's not the argument or what celestial theodolite does. It makes the closer prediction for the geometric intersection. But we got caught up in the deriving the elevation. So it is possible to derive the elevation, but it's going to be an estimate based off of the celestial sphere model. So it could be off by a little bit.
Can I time an occlusion?
Yo.
See, you know what I'm going to ask, don't you? And the answer is no. Can I time an occlusion, put stellarium on the peak with atmosphere off, read the indicated star altitude angle from stellarium, and have that be the correct angle to the mountain every time?
Yes.
Okay.
Every time it will be closer than what the globe predicts for their geometric intersection. Every single time. And if you subtract the difference at the time of occlusion where the star's true position is from the mountain peak, you will get exactly that offset. So yes, you can. Mm-hmm. So here I was incorrect in saying that, because to subtract the intersection difference, you have to already know the elevation of the peak. So that would be circular. That's not that's not the correct answer to that. The original answer should have been just stopping at it'll be closer on the intersections, because deriving that that difference will be, there's going to have an error in it dependent on this difference in the celestial sphere model to the ground, because we both share the same arc length in the sky, which has the same gamma relationship. That's the whole point of this.
You don't
Except
find
if
that
the Earth
odd,
were- and if-
Jesse?
and if
That
the
you're
Earth
off
were a
by the
globe-
amount of drop? Sorry.
Dude, if the Earth were a globe, you could do the same thing in reverse for the globe and align it to the globe and show how much flat Earth would be off.
Exactly.
so
There's a reason why Dr. Mike is a flat earther now.
so the problem is, though, when we do the method, stellarium at the peak, atmosphere off, the angle does not always match the flat Earth prediction. In this case, it was off by 24 meters for Varley SE2.
Okay. I don't think he's getting it.
I mean, if you yourself there predict that the globe angle would be 4 degrees.
Jesse,
Let's see.
if we're both using the same arc length, right, and the sky is referencing that same arc length, right, and the globe is off by what they predict as Earth curvature, and the half central angle, that curvature of that arc length is always proportional to the arc length by half, then there's going to be an error computated out of that offset, because one is a flat Earth prediction with a flat baseline. The other is a globe, assuming an elevation difference of 4 arc minutes in this case for the SE Varley. Now, what was measured was the globe was off by double their amount of what they predicted for elevation, which automatically will give this amount for the flat Earth angle to it. So we already went over, if you subtract those out and align it to each frame respectively for what they predict, you will see the air difference in the globe versus the air difference in flat Earth. That's why I showed you Pikes Peak versus Pikes Peak as a globe. And you could see, oops, 1 second. You'll see that this number here, this E theta, right? This is the offset between the two at the peak. If you subtract this from the star's true position, you get the elevation of the mountain. And if you subtract it from the observer location true position 2, you get 204. So instead of being at 206, they're now at 204. And then if you add the central angle back, you get what the globe would predict geometrically at 217. So now this is real important, because when I switch this, watch what happens. This 2 arc minute air is going to become 13 arc minutes if the elevation difference leaned towards the globe. They would be reversed. We would be off by this amount. We subtract that difference. We get the true elevation to the mountain. Same offset for the globe, because they're going to subtract this amount for their
Drop.
for their observer location. So that's going to offset them by that. And then adding the half gamma back is going to put them back at 217. So if the Earth were a globe, the offset measurement that you're trying to pigeonhole into us is an offset created by the fact that the Earth missed their alignment. And then to turn around and say that this is a strawman of the globe to even reference this is ridiculous, because we could show that the root of the air is a proportional geometric relationship to what the globe predicted as drop over distance for their geometric alignment.
Yeah, real quick.
Well-
Don't leave that page real quick. Do you see G12, Jesse?
For some reason his stream is really clunky for me.
Okay, do you see
G-
G12?
I see G12.
Okay. Do you see how that angle matches what the globe predicts in terms of from the observer, right? From the observer to the mountain peak with refraction for the star.
Okay, so is that turning on atmosphere in stellarium for that case then?
No, this is just the geometric alignments.
So there's zero globe error then. You're saying so it matches the globe perfectly there.
Yeah.
Didn't
For-
you
for
ask a
geometric
question,
alignment, yes.
Theodolite?
Yeah, I did ask a question, but that's okay. So you see how it says 0?
I
There's no
see.
like
That's
that
H.
was that. Mm-hmm.
I see the 0.
Okay. This is what it would look like if it were to match a globe. Now go back to what it actually showed. Do you understand now, Jesse? You guys are off by the same amount that you predict the drop is.
Well, I explained to you. The no glober agrees with your
No shit.
your
Yeah.
your H.
No shit. We
your,
get it. You're in a belief system. It's funny. It's fine.
Well, I mean,
An appeal to
it's
the
a straw
consensus
man.
literally
You need to
means
find
nothing. How's it a
all
straw
the
man? The
people
French
you're-
did it, bro.
no. Well, I don't think they did. I think they did correct for refraction. If you were to
They
correct
did
for
correct for
astronomical,
it by subtracting it. Do you understand that? Because they need to reference the true position. They're doing the
So-
same thing we did.
so
All we're doing differently is adding the arc length back to check what flat Earth would predict.
so where are you subtracting refraction?
Right here where it says true position for the observer, that is the apparent position minus the true position. And that gives us 13 arc minutes of refraction as reported by Stellarium. Their formulas given by Stettleman and Bennett give 12 and 13 respectively.
So
The
how
other
come?
refraction calculations, they all agree with each other, Jesse.
Yeah. So apply that refraction then to H 13. If I understand your sheet here. So see, the French, they knew the apparent angle to the star, and then they subtracted refraction to get the true angle.
Correct.
We also are going on the apparent,
Oui.
and we're not subtracting it here. That's the problem.
That's your problem, not ours.
Well,
But anyway, dude, that's why I'm
Hold
It's
on, I want to
been-
hear
it's been
his
a-
justification real quick, Alan. We gotta
Yeah,
nip this in the butt.
go
What do
ahead.
you mean we're not doing that?
Nip it in the bud is the proper term, not butt.
Sure.
well, the H13. That's that's based on the true position from Stellarium, right?
Yes.
But at the time, according to the globe model, at the time that the star is occluded, it does not appear at its geometric position, correct? It appears above its geometric position, right? According to the globe model? But by the amount of astronomic refraction?
Sounds correct.
Beat that?
Okay. So, right here for 39 Aquarii, if we take the amount that they were off by, oops, that's the wrong. What did I miss your H3? F13.
Put
Mhm.
HF by accident.
Did I know? 13, there we go. Okay. So we can see the differences now for refracted position and geometric intersection. So let's see.
I think you
here.
got your
If they
sign
put-
backwards.
Yeah. Well, it doesn't matter because it'll
Well,
some of them
no,
some of them
it
will
does
be
matter.
positive
The
and
order,
negative
the
either
order
way.
matters.
So we
You
can
need to
do,
change the order. Yeah.
some of them are going to
B16
end up being
minus-
above and some are going to end up lower. So I'm just going to do absolute if is that all right with you? But
No.
that also
No. You need to. You need to.
Listen.
You need to
Listen
change
real
the order.
quick. Jesus, dude. The sign difference also, depending on occlusion or emergence, is also going to change. So
No, just change F13 with B16. That's just swap
Just
the
do
order
it.
of them.
all right.
You forgot
All right.
the F and the B.
Did I?
Yeah.
Looks. What do you mean?
B16 minus F13.
Oh, I did it. I just did the numbers. I see. Gotcha. There we go.
Same number.
150
Hey, look at
thrice.
that.
What?
Had nothing to do with
150
it.
thrice. So, and then we're gonna have to end up changing it again when we do a different one. So anyway.
All right. So now, so this is the 1 minute and 53 or 54 arc seconds. That is the error between the globe, celestial, theodolite, and reality, right?
Sorry, which one? What did you say?
The 153 there, your new pink. That's
Yeah,
okay.
153 is refraction amount minus the intersection difference aligned for the globe.
Okay, now
So-
go to
Mhm.
SE Varley.
Okay.
All right. So we have an error of 39 arc seconds. What is the flat Earth error here?
4. But this is considering apparent position, which isn't the geometric alignment, but anyway.
Right. So that 39 arc seconds there you got. I would have to check your math, but that is probably what I would not consider a straw man. That would be a correct representation of the globe right there.
All that's
So if you wanna-
all that's doing is adding refraction back in to say that it just so happens to align with what the flat Earth predicts at the time of occlusion. And this doesn't in this relationship doesn't hold for all the other peaks. You end up in scenarios where you're above the peak or below the peak at the time of
Right.
occlusion.
Try North Peak.
So okay. Let's just do them all.
Yeah.
Let's start with Pikes. So Pikes Peak, we got 2. Oh, let's call it 2. For Blajet, we have 2 over the peak. So you predict to be still above the peak. That's inconsistent. That's let's see.
Although 2 arc minutes is not that big of
for
an.
Cheyenne. You say it's not that big of a deal, but if this
It's 8
is
seconds.
but if this is the reported amount, and like you've done the occlusions yourself, you know how they move in the telescope at 1 second rates. Like it's perfectly measurable. And if the star is reported to be 2 arc minutes above it geometrically, then that's not an occlusion. That's why we reference the geometric positions. We're not concerned with the refraction shit. Because like how much it's going to change it by is in contention. That's why we go off geometric alignments. So for Blue Mountain here, 2 arc minutes above the peak still. Like actually this is already represented in the geometric analysis right here, because these numbers are all the same. So what we have up here in
Oh, yeah, it
predicted
is.
time. What we have up here for G predicted time is just the apparent position minus the geometric position for the intersection.
Yeah, I know.
And
And
so
Let's go to Varley
hold
real
on
quick.
a second.
Jesse, you're getting crushed.
So we
Oh,
have
no.
we have the scenario where it's reversed, where instead of having a 38 arc minutes difference for the apparent position at SE Varley or whatever, we have a 43 arc second difference for flat Earth prediction. It's like the using the apparent is inconsistent, and here it's saying that it's going to be 2 arc minutes above the star. Yeah, I have these notated for the sign differences. So if it's negative, it's above; positive is below. So on Mount Rosa, they predict to be 2 arc minutes above the peak still. None of this, and if like this refraction amounts were legit, they would be like a 1-to-1 relationship to how much the gamma is off on them, and it's never that.
Yeah, let's go back to
So
Varley
hold
real
on.
quick. Are you gonna do everyone?
We're doing them all.
oh, I see. The reason what you haven't
Hold on.
accounted for terrestrial refraction. So that's why the globe prediction
What, dude?
would
You
still
just
be
said that
off a
that
little
was
bit.
not
Okay,
you said that was the globe, bro.
One second. You're right. I do not, because an apparent image doesn't cause an occlusion. There's nothing there to physically occlude light rays. So what
We
would happen
disagree on that.
is
But okay.
we certainly do, but for the globe, for the globe enthusiast, there is the geometric plus terrestrial refraction in apparent position comparison here too. So down here, apparent peak and apparent star difference is a mismatch by 2 arc minutes as well, and it ends up being still 2 arc minutes off instead of being 4 for Green Mountain. So there's still no relationship between the alignment. Like it looks close on Pikes Peak or whatever because it's what was it, 217? They predict like 219. Like it looks close on that, but on other ones it's not even close. There's no relationship to it.
Try North Peak.
We're getting there, bud.
Okay.
So at North Peak here, you predict to be 3 arc minutes above the peak for the geometric alignment for the globe. So that doesn't help either.
That's 3 arc minutes is about that, the terrestrial refraction. So if you
if that were present in there, like then you would be looking at this timing here where it would be 2 arc minutes off. So if we add terrestrial refraction to that peak, it's going to be 2 arc minutes and 30 arc seconds off. So it would have occluded 30 seconds later versus the geometric alignment for 40, it would have been 46 seconds later. So in either case, that doesn't help at all. That's why we don't, it's not a factor.
So which is closer, the flat Earth method or the globe Earth method here?
Flat Earth is minus 13 off, and the globe is off by 21. So globe
No,
is off.
I mean using the globe method that I approve of, the Globers approve of. The 3 versus 13. Right? So that one's using the
3 isn't what was measured though. So in order for this to be relevant, you would have to wait another 46 seconds.
Real time.
So the occlusion had nothing to do with this relationship.
well, and
It already got occluded.
it also
So
had
you would
nothing to
then-
do with the
So it has nothing to do with what? The elevation difference between flat Earth and globe? Well,
Well, look
that's
at
where
the-
you're wrong, because when we correct the offsets, the gamma amount shifts to the globe being off, and when we correct it for the globe, the gamma ends up being off by flat Earth. So you're
Yeah, but
incorrect.
look at the predicted FE time. 3 minutes off. That occlusion shouldn't have happened within 3 minutes of that.
And as I stated, over this same arc length, we share the half gamma elevation difference between our models. So when the globe misses their intersection difference, we get left over with the remnants. So nothing about this. The star relative to the observer traversed that arc length and hit a mountain with a rise over run to the peak. And at that time, the geometric relationship between the half gamma over that arc length gets split between how much the globe, but between how much curvature there wasn't. So of an expected 1,300 meters of drop, they were 1,800 meters off. And then the rest of it gets split to us at the other end of that peak because we're at the other end of the rise, we're at the other end of that arc length. So we
I have
get
a
the difference on that. Go ahead.
Would you consider adding a line just below 13 there in the pink that uses a method that us globers approve of, so at least there's a globe method in there that we don't consider a straw man?
Again,
You don't have to do it right now, but would you be willing to do that?
It's already in here. And again, appeal
Yeah.
to consensus means absolutely nothing.
Well,
But
if you're
that
telling
number is already
people-
in here. So real quick, Jesse, that number's already in here and it didn't help. Like now, what would you like me to do?
but if you're telling people
That number's already in here and it didn't help. Now, what would you like me to do? The thing you're requesting is already in here. Now, what would you like me to do?
Isn't that number that didn't
Can I
help
help
the one
you?
that's like 4 times closer than the flat Earth numbers?
Can we go to Varley? Let's go back to Varley where you said, "Yep, I agree. That's the globe." Let's go right back to that one. Okay. Now let's look at the apparent. 1 arc minute. 1 arc minute of terrestrial refraction. I just saw it on the bottom. So again, Jesse, how is this helping you?
Well, for them on the apparent here, it would reduce it down to arc second differences. But then on other measurements, when it doesn't, it becomes inconsistent. So like I said, that's why we don't consider refraction. It provides nothing useful in terms of the change in the half gamma relationship at the time of occlusion over the arc length. It's not a factor. That's why Goose, his conclusion in his paper was that, it doesn't have anything to do with why the stars appear at different elevations because it's not affecting the occlusions at all. And, that's a huge problem. There should be some relationship to it, and there very rarely is. It appears to be coincidental.
So where is, because I see the 45 meter error there, where is the 2 meter error showing up in your spreadsheet? Because when you present this to people and tell everyone that you're representing the globers, but nowhere is a comparison made to the true delta height and your globe.
It's right there on the left.
Where's 2?
The
Where's
FE
the number
mode
2?
and
What are you even saying right now?
Point to the number 2 as a delta between celestial theodolite and the globe prediction.
The height?
I don't know what you're. I don't know what you're
He
saying.
he wants a number that shows the difference between the height, the delta height of the prediction. So see how it says 24 and 22? That's what he wants. He wants the difference there.
Yeah, see that the difference between 1398 and 1396 should be shown somewhere. That would be decent.
It is. It's down here in the shared sum error. Because like I said, it comes from this intersection difference. So the difference between those is what would be the drop over distance. That's the half gamma. It's right here. The thing
Okay,
you're
so
looking for
where's
is
the
on
2?
this.
Show me the 2. Value should be 2.
You're saying show me the 2.
Yeah, when
He just wants a slot for 2 meters for some weird reason.
There's no 2 meter relationship here. The difference between these two is created by these numbers here.
I mean,
so the difference between those is 428.
The celestial theodolite gives an angle.
Mhm.
With distance and tangent, that angle gives a delta height, right?
Mm-hmm.
1396. That delta height given by the celestial theodolite is being claimed to always be closer to the flat Earth prediction of 1424 in this case. And the delta of 24 is shown there. That's good. It would be very honest of you to also show the delta between the 1396 and the 1398. Just so that we can see.
It's already in there. You say it would be very honest if you did this thing, and that's a really weird manipulative phrasing, because one, it's already on here. Yeah, real quick, let me do a post edit. I'm pretty sure if I convert that 4 into arc meters or meters, it will be the same. It will be that 2 he was looking for. Give me 1 second. Shared air. So yeah, 22. So comes from the because they were off by twice. So yeah, it does come out to be 22 in that case. All right, but it is related to this offset. So this is the curvature amount, and this air difference is created by the intersection difference. So this 24 meters being off is all in relation to that air, to the sum of our airs, which is the drop over distance. So, and they always have double or a majority of it. And if they have double, then we end up with whatever the normal portion would be. Just in the form of the intersection differences, which we already covered, is what creates the elevation differences that you want to see the subtraction number to. But you can also subtract or add these differences depending on the sign of the measurement, and it will equal the drop over distance, or what the drop over distance value would be in meters. And that only works if this relationship here, the shared air sum, was also the same. And So like to phrase it as this weird, like, you would only do this if you were honest. I've already done it, and it's my premise.
Well, I think it's important for people to know that sometimes when you occlude a star, put stellarium on the peak with atmosphere off, take that angle, put it into tangent, multiply it times the distance, that it actually gives a delta height that matches the globe prediction. I think people should know that. Don't you think they would rather hear it from you than from me?
It's literally in the spreadsheet. You're making a mountain out of nothing. The differences are caused by the half gamma that we share, referencing the same arc length.
Okay, well,
So
are you willing to?
what you're requesting? Are you willing to acknowledge that what you're requesting is right here in this column? Are you like? Can we do that? If you can do that, I'll add the thing that you want to add. Good.
I don't see a 2. I don't see it. Are you saying it says shared error sum? I don't know what that means. Doesn't mean anything to me. I don't know what it means.
F14. F14 is our intersection difference for flat Earth minus F13, which is the intersection difference for globe Earth. That gives an angular amount of 4 arc minutes. That angular amount of 4 arc minutes is the half central angle of 4 arc minutes for drop over distance for the peak to subtract from the angular amount of the peak.
Oh,
the
cool.
thing that you're requesting, the elevation difference here, that is created by this intersection error or difference. That's why it's right here and highlighted in bold.
Okay, could you do me a tangent of the angle times the distance down there?
For this?
Or you've got it already. Yeah,
Sure.
thanks.
Oops. Let's see, is that referencing the, let's see, it needs to be, is it 40? 22.
That's not right.
Over distance.
No, I'm not. I don't want drop over distance. I want the difference between the celestial theodolite results and the globe predicted geometric results. Because the celestial theodolite is claimed to give the geometric angle to the mountain. And it's claimed to never match the globe geometric prediction closer than it matches the flat Earth geometric prediction. So
Jesse.
1396 minus 1398 is minus 2, right? So
yes. And the difference between this, right? The difference between this F5, or no, I'm sorry, H5 and H14 is created by this difference here. Right? So when we do our aired sum, we get the half of the central angle. That's what's predicted as drop over distance. So we're off by 24. You guys are off by 46. I'm sorry, 45 meters. So
which we don't agree to because we think that
I don't care if you agree to it or not. That literally means nothing to me.
How would you respond if the Globers were attributing some math to flat Earth that no flat Earther agreed to? Would you call that a straw man?
Ruhif tried to do that earlier, and I rejected the premise. If you reject the premise, you don't need to be here arguing it endlessly over nothing. Like, do you wonder why I don't talk to Ruhif endlessly? Because he rejects the premise and doesn't argue it. When it comes down to it, he just says, "That's rubbish, mate." We just went over it not being rubbish. The fucking French were doing the same thing. How could it be rubbish? It's only rubbish because it doesn't give a geometric alignment that's close to the globe. If the measurements came out reversed and it aligned with the globe, all of you globe lads would immediately accept it and use the geometric position. It would be the greatest thing since sliced bread.
So, no chance you'd be willing to add in
still.
Mic check. No chance you'd be willing to add in a line in the pink section called Globe Earth Results, so it's obvious to everybody, and add a line called How Globers Want It Done, or whatever. I mean, you don't have to say you.
This is a really weird social shame manipulation thing that you're trying to play, and all the information you're requesting here is right here, and we do presentations every Monday and openly discuss this with anyone who has questions. No one's hiding anything. Everything that you've requested in this sheet is actually already existing here, and now you're turning this into a weird thing where you're like, if you don't add this one thing, you're not honest. And honestly, dude, that means nothing to me.
Doesn't
I've
help.
already done the best I can to make this as open and public as possible. So to be like, do this one last thing to show this one other relationship where this is going to be off by 2, but then never acknowledge why it's off by 2 because there's no globe elevation geometric alignment with the star at the time of occlusion. Like, never acknowledge that part, but you want me to do this one solid favor for you. Like, dude, you go make your own sheet. Go do your own presentation on where you think the shit should be.
I mean, it is weird, Jesse. Like, you don't actually acknowledge the results.
What do you
don't
mean?
find that
Which
to be-
results?
You don't find it strange that the shared error between flat Earth prediction and globe Earth prediction is actually the drop over distance, the half gamma?
Well, the important thing is, can anybody occlude a star, put stellarium on the peak with atmosphere off, read the altitude angle from stellarium for that star, and know that that is, within a small margin of uncertainty, the true angle to that mountain peak? The answer
Yes.
is sometimes that angle matches
No.
the globe within 2 meters. Sometimes it matches a tiny globe. Sometimes it's 1,800 feet above
Hold
the
on.
flat Earth
No,
prediction.
Listen, so here where you're saying it matches the globe, that's a different comparison. We're comparing geometric alignments. If your hypothesis of refraction were correct, the gamma difference error between us would be different. That's not even what's shown. So that's completely unfounded. And again, you're just going to not acknowledge any of the significance of it and try to turn it around to like, oh, you're not acknowledging what the globe would say, and even though the globe predicts it's already above it. Like, even for your measurement, it predicts the refraction amount predicts that the star would have emerged it would be 3 arc minutes above the peak. It should have already emerged like 27 seconds earlier. That doesn't happen. No acknowledgement of that ever. Just straight to,
We go to that one?
hey, hey, if I subtract these two differences where there's a shared error and it's close to, in this case where it looks like that would be the drop over distance for what the globe would predict, I'm going to use that as my example. That's just rhetoric and retarded. Now, you wanted to go to Blinn or whatever?
Yeah.
Look at it.
Let's see if you
25 arc minutes
acknowledge
of
this.
refraction.
So
You see that,
here
Jesse?
we have, what's that?
Do you see that?
It looks like we have a globe error of 2.5-ish arc minutes and a flat Earth error of over 12 arc minutes, right? Am I seeing that right?
You have a position of a star that wasn't measured because it was geometrically occluded by a mountain, which had to have the full arc length traversed before it actually emerged. That's why the
actually
geometric
12%.
intersection errors are this, right? And the star didn't emerge 17 seconds earlier with the refracted position. It played no role in this.
So was the angle returned from stellarium at the peak with atmosphere off closer to flat Earth prediction or globe Earth prediction?
Flat Earth.
Okay, what was the globe Earth predicted angle that globers approve of?
The geometric angle is for the mountain peak would be 43 arc minutes, and the intersection difference between the true position is 22 arc minutes.
You see where he's getting that number from, Jesse?
Yeah,
He's subtracting the refraction.
Yeah, and then he's trying to just look at the apparent position and make it about that, and then hinge it on the globe, like another appeal to authority. Only the globe lads would use this position, which is already predicted that it would be above it. Never happens. Then in no case is it ever emerged earlier. But it's like somehow we still have to do this rigmarole. In no case is the half gamma offset proportional to the refraction amount?
Can you go to North Peak, please? Thank you. So that 517 meters of error, that's huge. That's almost 1,800 feet, right?
And the globe is off by 800. If you add those two together, you get the drop over distance amount. That's the half gamma. So
Well,
we're off because at the end of that central angle, there was an occlusion that occurred and the globe was off by this much. We get left over with the remainder. Deriving triangles based off of the off of the true positions at that time. 1 second, I'm almost done. Is based off of this intersection error difference. This is what creates it. Go ahead.
You keep saying the globe, but you're pointing at something that no glober supports.
No glober
you'll
supports it, but the other end of but the add total of that is the half gamma over the arc length. I could give a fuck if other globers support it. It doesn't mean anything. If they don't support it, that's because they don't understand that relationship is mandatory.
So you understand the globe model better than all globers?
Apparently.
I mean, oh. So how would you
if no one's willing to accept this half gamma relationship, then they're disavowing their own globe because it's proportional over every arc length. That's exactly what it is. It can't possibly be a straw man of it if it splits the error between the two and it equals the drop over distance amount, the half gamma amount between them. Can't possibly be an error. Hold on, can't possibly be an error if I can derive what the globe predicts off of positions of the stars. That's what we went over earlier tonight in the presentation for the physical elevations. We can derive all of that from the supposed offset when correcting it to flat Earth. And we could also do the same when we convert it to what the globe would predict, but that would make the flat Earth one off by the amount of drop over distance. So like going to this peak, like your go-to, why is this off by this amount, that and all that stuff. I've answered this multiple times now that we've understood the relationship of the gamma or half gamma relationship to the measurements. This is left over because the star got occluded at the end of that arc length for the observer. This is the leftover amount because the globe was off by this much for their geometric alignment. Saying that you don't agree with that is irrelevant. The math is the math and it's proportional. It exactly represents the globe. If it represented a different number that wasn't half gamma, then it wouldn't be representing the globe, and that would be a straw man.
So let's just say, for the sake of, we're obviously not going to agree on your method of representing the globe, which is bizarre because, anyway, let's just say, for the sake of discussion, that we both agreed Earth was flat. Let's just look at the green here. How did that 517 meters of error happen? That is way, way, way outside your own error bars for that reading, right?
It's left over by assuming that there's curvature on the ground.
Oh, hold on a second. What do you mean?
That's what the half gamma relationship. That's how it comes out.
Well,
you can't just that's what produces the error. So saying like assuming it's flat, we're using the celestial sphere model. So the angular relationship between these is always going to be, it's still going to be the same situation. And the implication to the offset is because the celestial sphere doesn't represent the ground. The stars don't actually go beneath your feet. There's no actual curvature. So there would still be an offset while using the celestial sphere model that's following 60 nautical miles per degree plus or minus lattice variance at 15 degrees per hour. Still going to be there. It's a product of the geometric relationship between the arc length and the gamma and the half gamma relationship of that arc length. Even in the sky, that's what we look real quick to show you this. We derive the same thing from just the positions of the stars in the sky, from taking observer location and peak location where the star's at. Subtracting that difference gives you the arc. I'll put it on Pike's Peak so it's more familiar real quick. Gives you that same arc length. So what you would be asserting as drop over distance for a physical model, that error is going to come out of that regardless, because the sky and arc length relationship to the half gamma is the same in that. So it's going to be proportional no matter what. It's always going to read this even if the Earth's flat. because we're using this coordinate system to represent it.
Well,
In other words, the whole entire arc length, right, from the observer to the peak, right, 27.
Yeah.
On Pikes Peak.
Like, yeah.
Okay, so it's
Like-
27 arc minutes, Jesse. Do you understand that, right? So that's the full gamma. Right?
I'm
With
still
me so far?
I'm
With me so
still
far?
I'm still lost on Alan's answer to my last question, which I think I specified specifically for the sake of discussion. Let's say we're both
Ask-
flat earthers. We
Ask,
don't
why
need
is there
to.
an error? He's explaining it to you, and I'm trying to also explain it to him. I'm trying to simplify it.
Let
It's a
me
product
see if
of
I can
using the celestial sphere.
let me see if I can steelman his position then, his argument. Are you saying then that stellarium does not give the true geometric angle to the peak when used
Nope.
according to the celestial theodolite? You're not saying that? So it does give the true angle.
With respect to 50 or 60 nautical miles, 15 degrees per hour, it's set at that rate, plus lattice variance. That's where it's predicted to be. Now, at the end of that arc length, that's all there is. There's just this distance between the observer and the peak on the ground and in the sky. We can derive this same offset difference from just the position in the sky. The difference here is an artifact of the ground not being flat. So this would still be the same relationship because the celestial sphere is still based on 60 nautical miles per degree, like that angular relationship. As we were going over earlier, someone said that the radius of the celestial, I think it was Ruhif actually, that said that the radius of the celestial sphere was set to 6,031 or 6,371,000 meters or whatever, the radius of Earth, which would, that's how they could make the celestial and terrestrial sphere 1-to-1. So in doing that,
Exactly.
from geocentric to topic centric, the whole model is based on that. So if the Earth is flat and we're using occlusions based on that system to reference, where the star should be at, you're going to get these. You're going to get these
You're gonna
differences.
get an error.
So actually, to answer your question, you're right. I did kind of misspeak. To answer your question, the relative to the observer, the star's true position at that time is whatever the rise over run to the peak is, because that's the only, like, that arc length there. If you were to do a complementary angle and figure out, like, the reverse of it, there's no other drop or distance that the star could move. It already got occluded. So it's like to complete a circle and to have it, come back into the same spot in the night or whatever, to get that relationship, it can't be different. So we're still going to have the same offset based on that relationship of the coordinate system.
Alan, could you pull up
And-
that diagram? Oh, sorry.
Yeah. So to answer your question, stellarium reports where the star should be for an observer based on 60 nautical miles per degree, 15 degrees per hour. And what the occlusions show is that the star's true position is not actually at that location relative to the observer. Otherwise, the occlusion would have happened earlier because the Earth would be a globe and that mountain would be lower as well.
So let's say I'm a flat earther and I'm going to use the celestial theodolite and I see a mountain. I'm going to climb it and I want to know, how much food I need to take. Okay. I need to know how high the mountain is. I occlude a star. I put stellarium on the peak. I turn off atmosphere. I read the star angle. I put that angle into tangent. I multiply it times the distance. In the case of North Peak, I will be off by 1,800 feet, right? In 1795 or something. Feet.
Yes.
So what caused that? Is there another step I need to do as a flat earther? Remember, I don't believe in the globe for this discussion. I'm a flat earther. I'm just using the method. and I need to know how to make it work. Obviously, there's plus or minus 10 or 20 or 30 meters of error, but not 517. What do I need to do to actually get the true height of the mountain that's not exaggerated by 1,800 feet?
Well, if you only had the distance between you and the peak and the reference point of the occlusion following the 60 nautical miles, you're going to be off of that based on that. It's going to produce the same amount.
Yeah, we're not trying to
That's
figure
where
out the height of the mountain, though.
That's where it's referencing the star's true position. If you did the same thing for a globe at the time of occlusion, you would end up, from observer location, you would end up being off by 885 meters. So, and then, like, you know, like I said, the difference between that, if you add these two together, it ends up being the 1341, which is the drop over distance to half central angle, that gamma relationship, or I'm sorry, that half gamma relationship we keep talking about, which is
Well,
represented by, excuse me, the celestial sphere, as we derive the central angle and half central angle here from just the positions in the sky, and then also the position, the gamma and half gamma from using the distance over Earth's radius times, you know, converting into decimal degrees. So same exact issue is going to be present regardless of the shape of the Earth, but the shape of the Earth is going to dictate how much we're off by on these measurements. So
no,
if
but
the Earth were, it's exactly that, and I've
I'm
shown
trying to
that earlier.
respond. I stopped because you kept talking. It was not the end of my sentence.
Go ahead.
So no, the globe or me would use a surveyor's theodolite, and I can peg that mountain within 10 feet. Okay, that's not a problem. But I'm talking about the flat earther me using the celestial theodolite. It looks like in the case of North Peak, it did not get the method did not give the true angle to the mountain, and there's no known reason why. Is that the current state of things?
Point of the method, dude.
No, dude, I can't stand when I explain the reason why it's off and then you turn around and say, so there's no reason why. Like, so this is one of the last times I'm going to repeat myself and also interact with you. So, you know, enjoy.
Thank you, by the way.
The distance to the peak is off because it's following a celestial sphere model. So it's putting the star's true position at a certain location at a certain time, regardless of whether or not the star's true position is actually at that location. And that's what's in contention. When you say, hey, I can whip out my theodolite and you know, clock the globe measurement, that's internally consistent in referencing the globe to itself and comparing the globe to itself. What we're doing here is looking at geometric intersections and seeing which model predicts the cause of the occlusion, the actual alignment of the occlusion, for one. Now, the shared air reference that you're keep referencing and keep trying to make about as if there's no answer, even though I've answered it multiple times. So we're sharing the same arc length over the celestial sphere. So it's going to produce this offset. That is, that's what causes it. So to say, hey, if I need to climb a mountain and I need to know how high it is based off of the angular relationship, well, you can get an estimate off of it, right? But it's not going to be exact, but it's going to be closer than what the globe predicts for geometric alignment to the peak at the time of occlusion. So that's all I really have to say about that is, and I showed the math. We went over that earlier tonight. The document is available if you want to go over it and, you know, critique it or tell someone or whatever. That would be, you know, you do you. But the angles relationship of the arc length are derived from positions in the sky and then can be used to derive the physical elevations for the globe and for flat Earth by taking the differences of them. So
It shouldn't be a
that's it.
relationship at all.
The
Well,
the relationship should be reversed. Now go
Yeah,
ahead and
exactly.
say whatever you're gonna say, and just know that this was the last time that I'm gonna say it. We share the same celestial sphere model, so the same arc length gamma relationship of how much it's off is going to be present in the terrestrial measurement, as shared by how much the globe is off geometrically. Go ahead.
Well, and let me say two things actually. One is thank you very much for talking with me. I do appreciate it. But my point is, do I understand correctly then that the reason Stellarium didn't give the angle that matched the mountain within the margin of timing and distance uncertainty is because of spherical assumptions built into Stellarium?
Yes, the linear relationship that we were talking about earlier with the stars moving at 60
60
nautical miles per degree
degree.
relative to the observer. At the horizon, they're lingering. I can put up a graph real quick and put it and show you. So like if you plot out the true positions, oops, 1 second. If you plot out the true positions at the time of occlusion versus the celestial sphere, you'll see the lingering difference that's happening, and that difference, oops, isn't accounted for in the in stellarium because it's they assume a sphere and all that. So
Assume ball. Yeah.
yeah. So it's all so perfect celestial sphere right here. I'll put the image too in chat. 1 second. Here it is. Okay, so anyway, so perfect celestial sphere line here following the 60 nautical mile per degree relationship, and then the star occlusions, true positions, like how they're deviating as they get lower. So in other words, like this lingering factor is is causing that offset, which gives us this relationship here because they're not following what the model actually predicts.
Yeah, the distance is crazy. That's why. Look at the distance, Jesse.
Thank you,
Well, the
Alan.
distance is,
I can
yeah, sorry, go
I
ahead.
can dig that.
Oh.
I can understand that. The idea that the that you're saying that the error, the 1800 feet, is caused by stellarium giving non-true angles based on built-in globe assumptions in stellarium.
Yeah, it's close, but this is what the air, regardless of the shape, is going to be this unless the Earth was actually a globe. Then your alignments would be different. And then maybe if your refraction hypothesis was substantiated, there would be more of a relationship between how much the gamma factor changes between us two. But
That's
it
why
So-
they
never
had to
seems to
do.
be. Oh, go ahead.
So that's why they had to do empirical curve fits for astronomical refraction in order to account for this difference, because this difference is known about, but it doesn't follow any general physical assumptions, right? So they just had to quantify it and then plot it, essentially.
Yeah.
So with
Piezo?
this,
I will be right back. I'm going to go to the bathroom.
Piezo, you're in. Tag. Ding.
hey, Piezo, how's it going?
I'm actually eating dinner right now. I just thought I'd throw that in there. What's up, man?
Oh yeah, good to hear from you.
Well, he's not able to change his screen, Jesse, but I want you to understand something real quick about the arc length. So do you see where it shows star peak true, C11?
Yes.
Okay.
58 4.8.
That's the actual occlusion. So at that time, boom.
But that's
Right.
not the true angle to the mountain peak. That's 1800 feet off from above the true mountain peak, right?
The true mountain peak is going to be 40. No, so the rise over run with the distance and the height is 44 arc minutes.
Okay, yeah. So that makes it 13 and a half arc minutes above the predicted angle.
Right. And what we just went over is that we share a arc length, right? So the rise over run, that distance gives us an arc length in the sky as well. And the air that we share at the time of occlusion is going to be based on that. So the star in reality was at 44 arc minutes. So that's the
58.
time of occlusion. That's the end of the arc length. There's only two things at the end of this arc length, or two possible things at the end of the arc length. One is the mountain with a rise over run of 44 arc minutes. The other is a mountain peak with rise minus, or rise over run minus globe drop over the arc length or whatever. And that gives 35. So, or no, I'm sorry, I misspoke.
9.
You misspoke. Yeah.
Yeah, 9.
54,
Yeah, 9.
58 for.
Yeah. So that gives them a geometric 9, which means that their alignment would have been, at 21:03:14. And our alignment would be at 21:11:38. Now, all we have is this arc length and the sky. Now, it's not 27 or we're on North Peak. It's not, what's the arc length here? It's a degree, I think.
Right there, 110, 110.31.
No. No, it's 110.31. So the arc length is 110.31 in both scenarios because we're using the same celestial sphere model. So that's where this air comes from at the time of occlusion, because over this arc length, right? This is the only distance it could be. It's not 1 degree 11 arc minutes. It's not 1 degree 9 arc minutes. It's the arc length, and this is what is dictating that intersection difference. So to understand why it's different in creating the air, but still gets occluded, that would be because the stars are not following the conceptual model of the globe. That's what my understanding has come to.
Okay,
Because the arc length relative to the observer was dropped into the sky, so the globe had a chance to hit it at this time, and it got hit at the end of that same arc length, but just at an earlier time. Go ahead.
So would you say that this built-in globe assumptions in Stellarium is also why, say, the Varley and the Blinn Mountain stuff does what it does, gave the results it did?
It's proportional across every single measurement. We show
Every
that
single
same,
star.
That same arc in the sky is separated by the true position at observer location and true position at occluding object location. Same exact arc length. If you look at this here in this new goose section that I just added, you'll see the half gamma. You'll see gamma derived from the distance or angular positions of the stars at those locations, and then half of that is obviously the half of the arc length, and then deriving it the traditional way using central angle theorem. So, and they produce the same value.
And there's two determining factors, or controlling factors, I should say, that affect this phenomenon. One is how low to the horizon, how close to the horizon the star is, and the other is how far away along the ground the mountain is proportional to that angle to the horizon. So, if you wanted to maximize this effect to create the most deviation physically possible, what you would do is you would find some place where you've got 100 miles or something, or 200 miles, some absurd distance away from a mountain in like a really flat
We're going
place.
to Alaska and doing Mount Denali. So
I can't wait for that one.
That would be the dream.
And then a mountain that's half of a degree above the horizon or something.
Mount Denali is going to be higher than Everest. I'm telling you, that's what we're going to find out.
That would be, but as I explained though, the reason as to why is because the celestial sphere isn't matching the ground. And
It's just a concept.
and that same relationship, like that gamma half gamma relationship, is true regardless, because it's just geometry. It either exists as curvature in the sky or curvature in the sky caused by curvature on the ground. And if these measurements were if curvature were caused by the ground, then these measurements would all be reversed.
I think maybe you've answered another one of my long-standing questions. I asked, previously, if it's true that at the moment of occlusion, the observer, mountain peak, and star are in a geometrically, conjunction, straight line with each other, wouldn't the slope of that line be the same over the entire length on a flat Earth? So it wouldn't matter where you put Stellarium, but you're saying that Stellarium, it does matter where you put Stellarium because it fudges the angle of that line because of its globe assumptions.
It's not that it's fudging it, right? It's just maintaining a consistent ratio, scaling symmetrically around the whole circle. And so if you, for example, start at the position of the occluding object, that's the way that you force the line, because we're assuming that the physical mountain, like using that location, right? We're assuming that we know that that's like a physical anchor point that's more true than the arc in the sky that we're trying to compare it to. So like a Stellarium is doing this arc in the sky thing, 15 degrees per hour, 60 nautical miles per degree. And that's an assumption laid on top of it. But like the mountain, we're anchoring to that as like physically real no matter what. And so if we use that and then force the line, comparing it to the mountain, that's how we're measuring the deviation.
That was a great scenario or summary, bro. That was awesome. Exactly.
So if there were, if there were two mountain peaks, one 50 miles away and one 100 miles away, and the one twice as far was high enough that, they like one occluded, like they both occluded basically at the same time. Maybe one's a little bit to the left and one's a little bit to the right, so they could actually both occlude a star like at the same time. Imagine two stars coming down, same altitude angle for the two stars, and one occludes on the near mountain at the exact same time the one occludes on the far mountain. Stellarium on those two mountains would give two different angles, right? They both can't. They can't both be
So
a
we
true
wouldn't
angle.
reference both mountains for the same star. We would reference each mountain individually, and then in the scenario where, because like the way that the question was first presented was where they're like in alignment where optically the lower mountain just happens to be at the same elevation as the further one or whatever, and I would
The same
reject that.
geometric. Yeah.
Yeah, I would reject that measurement because we're supposed to be like able to see the object actually doing the occlusion. Although mathematically, if you referenced it, from the proper locations, I'm sure it would work out still or whatever.
But
Yeah, what she said the first time, Alan. The first time, that was the answer.
But what I'm trying to bring to light is that stellarium in two different locations would give different true altitude angles to the same star if it was like on those two different mountain peaks.
Well,
They're two different distances, of course.
Yeah, two different mountains, two different stars, two different distances, two
And
different angles.
so you're saying basically that the only one of those is correct, right? They
No.
can't both be correct.
They would each be individually correct for the
They
individual
would
star.
both be individually correct. I don't know.
Oh, that's right. Okay. So basically,
All right.
the altitude angle indicated by stellarium is not actually the true angle, except at certain distance and elevation combinations.
Well,
Well,
it's
at certain zenith distances, rather, there's not much difference between the true position and the apparent position. But as we found that, even at 10 degrees, there's a deviation in the celestial sphere here that's happening that's, greater than what the globe would predict, starting even at 10 degrees, where they say, like, I think it's like, what is it, sub 10 degrees is where they start to cut off for using stars for cell nav or whatever, I think. But, the relationship here of their true positions, it's a conceptual model. If you reference it internally, with respect to itself, it's going to give you the correct positions. But based on these occlusions, that's why we're getting these offsets at the end of the same arc length, but at a different elevation than what the globe would predict.
What's also interesting is if, like, before this was ever done, if you'll remember, Alan, that one presentation Shane did where he did the dig on optics and optical compression and the non-linearity versus linearity of like our personal sphere of vision. There's a curve. There's a chart on there that shows a curve where the regions of like the angular distance, or sorry, the angle to the horizon or angle relative to the observer of whatever we're looking at, how stuff appears to move and go down to the horizon from 90 down to 0. It's not a straight line. It is a curve, and the middle section on that curve is linear, and then towards the ends there's slight deviations, and
Exactly.
Massive
that-
deviations. It goes
it gets
asymptotic.
Yeah, it gets really when it gets to 0, it goes crazy. But yeah, that same curve appears to match what we're measuring here with the celestial theodolite. So it's like, if that's happening with stars, the thing is though, is like if that's happening with actual stars, because the thing about stars is it's cool compared to like airplanes and stuff. Is that airplane's going to disappear. The star, we can see that star. What the globe assumes to be like infinitely far away or close enough to be treated as infinite, even though it's like bajillion light years or whatever, right? So when we see that getting really, really, really far out, it's simply going down. If it's supposed to be going behind a geometric curve, because that's the only thing that would block our line of sight, right? Because it's like in a distant galaxy or whatever. When it continues to appear as it compresses into the horizon and continues to appear and doesn't match what it's supposed to do, that indicates that the effect that is causing that curve is the same effect that's causing the disappearance. Right? Because if it was a physical disappearance, then it would be an ideal sphere and it would be a straight line. It would be a constant slope across that chart. But if it's an optical compression effect or an effect of geometric optics, then we would assume that curve in Shane's presentation, and we would assume that the stars would follow that curve, and that's actually what they do when we measure it. So even the disappearance of these stars can't be due to them going below the ground, or else they would follow exactly 60 nautical mile per degree relationship everywhere.
Dude, at North
Well,
Peak,
Well said.
the star's geometric position is actually 12 arc minutes below the celestial horizon, meaning it's 12 arc minutes below the equator, but it's coming up all the way over the, over all that curve at 2 degrees to or no, sub 1 degree actually. So
I feel like
however much like if there was no mountain here and you continue to see the star descend, everyone would be happy to say like, oh, there's this much
That much
actual
refraction to lift
doing
it back
it.
up.
But that's never the case, and that's never what's measured in the occlusions, like where it's consistent. There's a couple where it's like coincidental that we saw, or gets down to like a couple arc seconds. But like all the other ones, and then even referencing, if you were to reference the, what do you call it, the apparent position
Terrestrial
onto
refraction.
that, yeah, that wouldn't even line up either. It would have already been included, etc. Like it just there's no, or later, there's no consistency to it. So. Yeah, it's interesting that you point that out about that relationship, because this one was actually below the below the actual globe relative to the observer.
Yeah, my biggest problem with it, right? Like when I found out that you can use the 2-part layered refraction correction, like you do the local refraction, terrestrial refraction, Snell's law, like you do that, count for temperature and pressure and everything, and you get the correction for that, and then you take the resultant angle from that and plug it into the celestial refraction formula, like in Jesse's very first simulator, and you get, within plus or minus 1 arc minute of every star observation. When I saw that,
that was crazy.
yeah, when I saw that, I was like, hold on a second, like, what are they actually doing here? Because like I love physics. I'm like, I know how like refraction works, like regular refraction, right? You just pop and swap the variables, man, and it makes sense. But we go dig into celestial refraction and its history, and why they needed like a way to account for sub 10 degree stars not following this relationship, as we've been talking about. And it's like, well, where did the actual corrections themselves come from? Like, how did they come up with the correct corrections, right? Like, what did they do? And as it turns out, right, like we found out that they just did a whole bunch of measurements, recorded a bunch of data, plotted their data, right, and then made a curve, just kind of like we did, but their curve is showing this deviation, right, which Alan has one right there where the points don't match the blue line. And then they quantified how much those points didn't match the blue line and turned that into a curve fit with a quadratic, and that quadratic became the plug and chug correction formula that you just plug your angle in without any physical variables. And it's actually like a complex polynomial with 2 quadratics. Like a theta angle squared and a theta angle, and then plus something up top and same thing down bottom. And it's just like, man, this is literally just a quantification of their error that they're just, dividing back out in order to get it to match what it should be, quote unquote. And I mean, kudos to you for quantifying it, but that's that's not a real physical phenomenon. Physical phenomena are characterized by general solutions.
I mean, that sort of thing happens a lot in sciences as you go digging. Like it sounds bad to people who haven't looked at it a lot, but that kind of adjustment is all over the place because
we know.
Like including in sciences that nobody's going to argue with. Like you talk about, science of how a car works or stuff, you'll see that all over the place. I can't think of examples offhand, but I'm pretty sure I've seen them before. Like it's everywhere because that's sometimes the easiest way to do things.
Well, there's one. I mean, it's one thing to do empirical fits when you're just trying to like quantify a system. Right, that's one thing. And if that's all you're doing is quantifying a system to make something work, then fine, right? Like that's a very easy and good way to do it, right? That's a very practical way to do it. Everybody does that. But when you're actually trying to explain the origin of a phenomenon, right, that doesn't actually serve you any. That doesn't demonstrate any causal relationship. It doesn't serve the purpose for that. And I mean, to give you by way of analogy or comparison, right? I could say, like, if we were to do that same process, like Alan has this chart with all the, the raw angles with the atmosphere off and all the arctan rise over runs, and ours have deviations too. Our deviations are smaller than the glob, but I mean, everybody's still off. The closer we get to the horizon, everybody gets off, right? If we were to just do that same exact thing, take a curve fit, and then say, oh look, our points don't match the blue line. Let's spit out a complex,
A flat fit.
a complex polynomial, quadratic numeral or quadratic numerator
Honestly-
denominator, and plug it in that way, and just do a correction factor and make it a flat correction. It'll be a flat celestial correction. You could do that same thing. You could do it with anything. You could do that with anything.
Honestly, you can, and I would like to see you guys do it because, frankly, the thing about flat Earth is that it's not any one observation can be fit into a flat Earth model by changing what the model is. The more you guys do math, the more the math is going to be inconsistent with reality because the different things can't all fit together. You can put one thing into a flat Earth map, two things sometimes, but you can't put all the observations we have, everything together. So the more you guys do this math, like, yes, please come up with these corrections, build these formulas, give us something concrete to sink our teeth into, because that's when the contradictions are going to appear. As long as everything stays fuzzy, everything stays, oh, well, maybe it works a bit like this, then I can't prove maybe it works a bit like this wrong very easily. But you give me a mathematical formula, and yeah, I can bite into that and spit it out.
Globe is wrong. Give me an answer to everything.
Pretty much the globe is the answer to everything in terms of
Yikes.
anything related to it. Anything related. Like, obviously, it doesn't answer, God or, whether my car looks better in red or blue, but in terms of
Can I say something?
how
on that?
this celestial works, yeah. All right.
Oh, thanks. I just wanted to say thank you, Alan, for talking with me. I do really appreciate that. It feels to me like the celestial theodolite, it's like flat Earth needs something that isn't thwarted by globe assumptions to really be convincing. Does that make sense?
Nope. You can definitely externally test an internally consistent model using this. And we can derive the same angular offsets based on positions of the stars alone rather than positions of the ground. So no, I reject your conclusion.
So you don't think it would be better if flat Earth had a way to prove flat Earth that didn't appeal to globe assumptions?
Appealing to globe assumptions are you talking about testing the globe to see if their assumptions are true? Like, what you're saying is preposterous.
No,
saying
I'm
don't
talking
test
about
our model and come up with a flat Earth exclusive thing. Okay.
No,
So no.
I'm talking about the extra 1,800 feet for North Peak. The answer was globe assumptions.
We already went over that. Yeah, we already went over that relationship. And even if the Earth were a globe, those differences would be reversed, and it would show that the Earth is a globe. So this still works just fine. There's actually nothing wrong with it at all. You're trying to get like some idealized perfect system out of it that would require much more accurate relationships to the true positions of the stars, and that's something that nobody can really know. The model is based off of assuming a linear relationship to them that isn't true. We could definitely test to see if that's true, and using the null hypothesis methodology, right? The Earth's either flat or it's globe. If it's a globe, these intersection differences are going to be closer because that's going to be the cause of the occlusion. Never is, never once. So we can perfectly do what we're doing and make a conclusion from it very easily. I wouldn't say what you're saying at all.
I did have a question about the null hypothesis. Is it true that the null hypothesis is that Earth is flat?
The hypothesis is that the Earth is a globe, and the null hypothesis is that the Earth is flat. You could swap them to your liking.
Right, and our goal here is to refute the null hypothesis, right?
Mm-hmm.
So, how much non-flatness would the celestial theodolite angle have to show in order to refute the null hypothesis, or is it irrefutable, like unfalsifiable?
No, as I said earlier, if these air offsets were reversed, the Earth would be a globe. It would be the direct implication. The null hypothesis would be falsified if the airs were reversed. It would be so goddamn conclusive. I would be here arguing against all the flat earthers.
Yeah, like if Glob was closer on all of them instead of Fe, then he would say, "Oh, well, I guess the null hypothesis is refuted because every single measurement we take is closer to cell sphere."
Actually, most of them are closer to the globe when
No, using a different
when
methodology for analysis,
yes
dude.
when
So if you're an honest person, when you go to interject and say that the globe's closer, make sure you clarify that you're not doing the celestial theodolite and you're now introducing a different method. That would be super dope.
well, it is odd that you have to introduce a different method for your H13.
What?
I
H13
don't
is
know.
based off of the observer's location
We're not
at
gonna
the
go
time
over
of
it again.
occlusion. We went over that with the French doing the exact same thing. So you can't just keep doing this like, I'm going to circle back to this thing, pretend I didn't understand when we went over it over and over again. We could just wrap up the conversation and be good instead of you trying to get some weird last word as if you didn't hear the explanation to these differences and what they are and how they relate to the globe. You're just going to gloss over all that, call that a straw man and shit. That's a really sophistry, dog shit way to argue. None of what you said regarding that actually changes the occlusion differences. You asked me directly if our method was falsifiable and could falsify it. I said yeah, and explained how. You just changed the subject to a different thing to start talking about a different comparison.
Well,
When there's
I
no relationship shown to the refracted position and the gamma, the half gamma air. So your hypothesis is invalid. You should null hypothesis what you're saying first before asserting it and see if it actually holds true. Because we've already done this. We've been doing it for 36 weeks now. So let's have a good night and call it, it was a good run. We had a great conversation.
I
thank
think
you,
it was
Alan.
edifying for most of the people in here. They're still listening intently.
Yeah, I've been waiting for you guys to chat, so this was a good convo. Thank you, everyone.
Alan,
Yep.
good shit, bro.
NP.
You already ended your stream and stuff, right?
Mhm.
Okay.
Actually, quick question about the fact there's been dozens of these. Are the old ones archived somewhere? Like, are they? Where would I go to look for those? If I'm curious.
Sorry, say that
Alan's
again.
channel.
Oh yeah, that would make
Sorry.
sense. Okay.
What was the question?
Where
Oh,
the
I was just
archive
wondering
ones.
where the old ones were archived, but your YouTube
Oh,
channel would be
oh.
the obvious place. Yeah.
Oh yeah, I have a YouTube playlist called Celestial Theodolite.
Okay.
All right, lads. I'm gonna head off now.
Oh, running away.
And here comes Ruhiv to shit on the whole thing. That's so funny.
No,
You did good, Alan. Let's go. Let's get out of here.